Okay, so today we'll be going over a long answer problem that I missed on the midterm exam. The problem is a Henderson-Hasselbalch type problem where you use a buffer to alter the pH of a base or an acid. And some prereqs we're going to need to know is we're going to need to know how to find the pH of a weak base or acid. We're going to need to know that the buffer slightly alters the pH of the given solution and how it's supposed to regulate the reaction. Know how to convert from molarity to moles if needed to do so. Know which is the base and acid in the formula and which is its conjugate pair. Also the equation for the Henderson-Hasselbalch, which is pH equals pKa plus log of base over acid. And finally, the conversion from Kb to Ka and vice versa. So the problem is a 100 milliliter buffer solution is 0.1 molarity of NH3 and 0.1 molarity of NH4+. Assume there is no change in volume for all cases. So it's not given, but the Kb value is 1.8 times 10 to the negative fifth, and you use that value because the NH3 is the reactant. So you're going to calculate the pH of the original solution. You set up the equation, and since you know that the amount of base is equal to the amount of acid, you know that the log of base over acid will equal to 0 because log of 1 equals 0. Then you just solve for Ka, so you use Ka equals Kw, which is 1 times 10 to the negative 14 over to the Kb, which is 1.8 times 10 to the negative fifth, and your Ka answer comes out to being 5.55 times 10 to the negative 10. For your pH value, you know the pH of the pKa is equal to negative log of the Ka. So you plug that in, and your pH value for the original solution is 9.25 pH, which shows it is basic. Now you calculate the pH when 0.004 moles of KOH is added to the solution. You switch it up because you're adding base to the acid. So you set up an ice chart, and you know that you start off with this is where you convert from molarity to moles. So you have 100 milliliters of NH4 and NH3, and so you just multiply the molarity by the liters, and you get 0.01 moles of both the base and the acid, and you add the base buffer. You subtract the base from both sides. You subtract the base from the acid, you add it to the base, and you get the pH equals the same pKa value because that doesn't change, but all you do is you add 0.04 to the top part, which is the base, and you subtract 0.04 from the acid, and you get a pH value of 9.62, making it more basic because you added a base buffer. And now we will calculate the pH when you add 0.003 moles of HBr to the original solution. And since we know we can just add the extra moles to the acid and subtract it from the base, we can just plug it into the equation of the Henderson-Hasselbalch. So what we get is pH equals 9.25 plus the log of the 0.01 minus 0.003, which is 0.007, over 0.01 plus 0.003, which is 0.013, and you get a pH of 8.98, making it slightly less basic as the first two. And now we'll be adding 0.015 moles of HCl to the original solution. And since you know that there's an excess amount of acid being added, which is 0.005, you know that it will completely dissociate. And since you know it's a strong acid, it will change the pH much more. So since you know that the base will completely dissociate, and you're left over with the excess strong acid, you take the pH of the strong acid, which is pH equals negative log of 0.005 moles molarity, because you divide by the 0.1 liters, and then your pH value will be 2.301, which is very acidic.